Hi viewers, so we meet again, and in today's lecture we will talk about animation and describe how it can be used in multimedia. In this discussion we learn the principles of animation, the animation techniques, how to choose the correct file types for animations, and lastly discuss how to create computer generated animations from multiple still images. By definition, animation makes static presentations come alive. It is visual change over time and can add great power to your multimedia projects and web pages. Many multimedia applications for both Macintosh and Windows provide animation tools. You can animate your whole project or you can animate here and there, emphasizing and adding spice. For a brief product demonstration with little user interaction, it might make sense to design the entire project as a video and keep the presentation always in motion. For speaker support, you can animate bulleted text or fly it onto the screen, or you can use charts with quantities that grow or dwindle. Then give the speaker control of these eye catchers. In a parts assembly training manual, you might show components exploding into an expanded view. Visual effects such as wipes, fades, zooms and dissolves are available in most multimedia authoring packages, and some of these can be used for primitive animation. For example, you can slide images onto the screen with a wipe, or you can make an object implode with a close effect. But animation is more than wipes, fades and zooms. Animation is an object actually moving across or into or out of the screen, a spinning globe of our earth, a car driving along a highway, a bug crawling out from under a stack of papers with a scream voice from the speaker telling you to shoot it now. Until videos became more commonplace, animations were the primary source of dynamic action in multimedia presentations. Principles of animation. Animation is possible because of a biological phenomena known as persistence of vision. An object seen by the human eye remains chemically mapped on the eye's retina for a brief period of time after viewing. Combined with the human mind's need to conceptually complete a perceived action, this makes it possible for a series of images that are changed very slightly and very rapidly, one after the other, to seemingly blend together into a visual illusion of movement. The illustration shows a few cells or frames of a rotating logo when the images are progressively and rapidly changed. The arrow of the compass is perceived to be spinning. Digital television video builds 24, 30 or 60 entire frames or pictures every second depending upon settings. The speed with which each frame is replaced by the next one makes the images appear to blend smoothly into movement. Movies on film are typically shot at a shutter rate of 24 frames per second, but using projection tricks, the flicker rate is increased to 48 times per second, and the human eye thus sees a motion picture. On some film projectors, each frame is shown 3 times before the pull down claw moves to the next frame, for a total of 72 flickers per second, which helps to eliminate the flicker effect. The more interruptions per second, the more continuous the beam of light appears. Quickly changing the viewed image is the principle of animation. Animation by computer. Using appropriate software and techniques, you can animate visual images in many ways. The simplest animation occurs in two-dimensional space. More complicated animations occur in an intermediate 2.5D space, where shadowing, highlights, and forced perspective provide an illusion of depth. The third dimension and the most realistic animation occurs in three-dimensional space. In 2D space, the visual changes that bring an image alive occur on a flat Cartesian x and y axis of the screen. A blinking word, a color cycling logo, a cell animation, or a button or tab that changes state on mouse rollover to let a user know it is active are all examples of 2D animations. These are simple and static, not changing their position on screen. Path animations in 2D space increases the complexity of an animation and provides motion. For example, changing the location of an image along a predetermined path during a specified amount of time. Authoring and presentation software such as Flash or PowerPoint provide user-friendly tools to compute position changes and redraw an image in new location, allowing you to generate a bouncing ball or slide a corporate mascot onto the screen. Combining changes in an image with changes in its position allow you to walk your corporate mascot onto the stage. Changing its size from small to large as it walks on stage will give you a 3D perception of distance. In 2.5D animation, an illusion of depth, the Z axis, is added to an image through shadowing and highlighting, but the image itself still rests on the flat x and y axis in 2 dimensions. Embossing, shadowing, beveling and highlighting provides a sense of depth by raising an image or cutting it into a background. 3D Invigorator, for example, provides 3D effects for text and images, and while calling itself 3D, works within the 2D space of image editors and drawing programs such as Adobe Illustrator, Photoshop, Fireworks, and After Effects. In 3D animation, software creates a virtual realm in 3 dimensions and changes are calculated along all 3 axes x, y and z, allowing an image or object that itself is created with the front, back, sides, top and bottom to move towards or away from the viewer, or in this virtual space of light sources and points of view, allowing the viewer to wander around and get a look at all the objects, parts from all angles. Such animations are typically rendered frame by high-end 3D animation programs such as Newtek's Lightwave or Autodesk's Maya. Today, computers have taken the handwork out of the animation and rendering process, and commercial films such as Shriek, Toy Story and Avatar have utilized the power of computers. Animation techniques. When you create an animation, organize its execution into a series of logical steps. First, gather up in your mind all the activities you wish to provide in the animation. If it is complicated, you may wish to create a written script with a list of activities and required objects and then create a storyboard to visualize the animation. Choose the animation tool best suited for the job and then build and tweak your sequences. This may include creating objects, planning their movements, texturing their surfaces, adding lights, experimenting with light effects and positioning the camera or point of view. Allow plenty of time for this phase when you are experimenting and testing. Finally, post-process your animation, doing any special rendering and adding effects. Cell animation. The animation techniques made famous by Disney use a series of progressively different graphics or cells on each frame of movie film which plays at 24 frames per second. A minute of animation may thus require as many as 1440 separate frames, and each frame may be composed of many layers of cells. The term cell derives from the clear cellulite sheets that were used for drawing each frame, which have been replaced today by layers of digital imagery. Cell animation artwork begins with keyframes, the first and last frame of an action. The series of frames in between the keyframes are drawn in a process called tweening. Tweening is an action that requires calculating the number of frames between keyframes and the path the action takes, and then actually sketching with pencil the series of progressively different outlines. As tweening process, the action sequence is checked by flipping through the frames. The penciled frames are assembled and then actually filmed as a pencil test to check smoothness, continuity and timing. When the pencil frames are satisfactory, they are permanently inked, photocopied onto cells and given to artists who use acrylic colors to paint the details for each cell. Women were often preferred for this painstaking inking and painting work, as they were deemed patient, neat and had great eyes for detail. In the hands of a master, cell paint applied to the back of acetate can be simply flat and perfectly even, or it can produce beautiful and subtle effects with feathered edges or smudges. The cells for each frame may consist of a text title, a background, foreground, characters and are carefully registered and stacked. It is this composite that becomes the final photographed single frame in an animated movie. To replicate natural motion, traditional cell animators often utilized motion capture by photographing a woman walking, a horse trotting, or a cat jumping to help visualize timings and movements. Today, animators use reflective sensors applied to a person, animal, or other object whose motion is to be captured. Cameras and computers convert the precise location of the sensors into x, y, and z coordinates, and the data is rendered into 3D surfaces over time. Computer animation. Computer animation programs typically employ the same logic and procedural concepts as cell animation and use the vocabulary of classic cell animation, terms such as layer, keyframe and tweening. The primary difference among animation software program is in how much must be drawn by the animator and how much is automatically generated by the software. In path-based 2D and 2.5D animation, an animator simply creates an object or imports an object as clip art and describes a path for the object to follow. The computer software then takes over, actually creating the animation on the fly as the program is being viewed by your user. In cell-based 2D animation, each frame of an animation is provided by the animator and the frames are then composited into a single file of images to be placed in sequence. Ulead's GIF Animator and Alchemy's GIF Construction Set Pro simply string together your collection of frames. For 3D animation, most of your effort may be spent in creating the models of individual objects and designing the characteristics of their shapes and surfaces. It is the software that then computes the movement of the objects within the 3D space and renders each frame, in the end stitching them together in a digital output file or container such as an AVI or QuickTime movie. On the computer, paint is most often filled or drawn with tools using features such as gradients, and anti-aliasing. The word inks in computer animation terminology usually means special methods for computing color values, providing edge detection and layering so that images can blend or otherwise mix their colors to produce special transparencies, inversions, and effects. You can usually set your own frame rates on the computer. 2D cell-based animated GIFs, for example, allow you to specify how long each frame is to be displayed and how many times the animation should loop before stopping. 3D animations output as digital video files can be set to run at 15 or 24 or 30 frames per second. However, the rate at which changes are computed and screens are actually refreshed will depend on the speed and power of your user's display platform and hardware, especially for animations such as path animations that are being generated by the computer on the fly. Although your animations will probably never push the limits of a monitor's scan rate, but animation does put raw computing horsepower to task. If you cannot compute all your changes and display them as a new frame on your monitor within, say, 1/15th of a second, then the animation may appear jerky and slow. Luckily, when the files include audio, the software maintains the continuity of the audio at all cost, preferring to drop visual frames or hold a single frame for several seconds while the audio plays. 3D animations are typically delivered as pre-rendered digital video clips such as Flash or PowerPoint. However, render animations as they are being viewed, so the animation can be programmed to be interactive. Kinematics. Kinematics is the study of the movement and motion of structures that have joints, such as walking man. Animating a walking step is tricky. You need to calculate the position, rotation, velocity, and acceleration of all the joints such as knee bends, hip flexes, shoulder swings, and the head bobs. Poser, a 3D modeling program, provides pre-assembled adjustable human models in many poses such as walking or thinking. Inverse kinematics, available in high-end 3D programs such as Lightwave and Maya, is a process by which you link objects such as hands to arms and define their relationships and limits. For example, the elbows cannot bend backward. Once these relationships and parameters have been set, you can then drag these parts around and let the computer calculate the results. Animation file formats. As we are moving towards the end of our discussion, we need to look at some file formats that are designed especially to contain animations so that they can be ported among applications and platforms with proper translators. These formats include Director, Animator Pro, 3D Studio Max, GIF89A, and Flash. Because the file size is a critical factor when downloading animations to play on web pages, file compression is an essential part of preparing animation files for the web. A director's native motif file, for example, must be pre-processed and compressed into a proprietary shockwave animation file for the web. Flash, widely used for web-based animation, makes extensive use of vector graphics to keep the post-compression file size at absolute minimums. To view these animations within a web page, special plugins or players are required. In some cases, especially with 3D animations, the individual rendered frames of an animation are put together into one of the standard digital video containers such as the Windows audio video interleaved format, QuickTime or motion picture expert group video. These can be played using the media players shipped with computer operating systems. So friends, this brings us to the end of our discussion on animation and the intricacies involved, and therefore we sum up. By definition, animation is the act of making something come alive. Depending on the size of the project, you can animate the whole thing or you can just animate parts of it. Visual effects such as wipes, fades, zooms and dissolves available in most authoring packages are a simple form of animation. Animation is an object actually moving across, into or out of the screen. Animation is possible because of a biological phenomena known as persistence of vision. With animation, a series of images are changed very slightly and very rapidly, one after the other, seemingly blending together into a visual illusion of movement. Cell animation, an animation technique made famous by Disney, uses a series of progressively different graphics on each frame of movie film. Some file formats are designed specifically to contain animations, and they can be ported among applications and other platforms with the proper translators. Making animations appear natural requires a basic understanding of the principles of physics. So that's it folks about animation. See you in the next lecture on videos. Thank you very much.